Hello, everyone, and welcome to the final day of Bootcamp week for the IWD 2026 Global Techathon. It's been an incredible journey of learning here and innovation and inspiration. And we are so excited to wrap up this week with another impactful session. And I'm Neha, and I'll be your host today as we wrap up this exciting week of hands on learning and skill building. To all of you who have joined us throughout this week, whether you have been here every day or turning on for the first time, your engagement and enthusiasm have made this week truly special. For your final session, we have another amazing speaker who will take us on practical uses of data and artificial intelligence. Leading us through today's session is Blessing, who is an alumni of the Teens in AI Techathon campaign, a data scientist working on agentic AI at Turning Enterprise. Currently pursuing an MSc in Applied Social Data Science at London School of Business and Economics, with a focus on applying emerging technologies to improve human lives, she will ensure we make the most of our time. And not to forget, she's our data guru. So let's get this last session started and let's dive in one last time.
Hello, everyone. My name is Blessing Oludele, and I have the rare privilege of taking the last session for this. So I would quickly share my screen so everyone can see my presentation. Like Neha said, my name is Blessing Oludele. A brief intro about myself is I am a Teens in AI alumni. I joined the 2019 cohort. Yeah, I joined the 2019 hackathon. Then I went on to start practicing data science. I first worked in a data center in Nigeria before joining Turing, where I work on AI projects, generative AI agents and things like that. And currently I am in LSC here in London for a master's in applied social data science. So yes, today's session, the previous sessions have been very technical and they've taught everyone so much. We've learned about agentic AI, we've learned about Figma, we've learned about how to actually get a job in the space and the career strategies you should use. But today's session is going to be a bit more practical. Now that you have like the technical skills, you know how to pitch. How do we actually apply that? How do we apply this data and AI knowledge we have been getting throughout the bootcamp? So first, I would talk about what's data because a little summary wouldn't hurt. So I'll just do a brief recap about what is data. Then I would go on to something I call becoming a data head because a data head is my terminology of someone that actually applies these things. So you're moving from the theory to actually looking for problems to actually use the data. You're thinking data and you're thinking problem solving essentially. So I call it becoming a data head. So ignore my yeah. Then we have a short interactive session. Then we are going to talk about ethics and a practical example if we have so much time. So what is data? Data is simply information, any information that can be recorded. And why now? Why is everyone talking about data science, artificial intelligence, and things like that? And it's now because big data has become a thing. We can now record more information because of storage. Storage has become cheaper. Compute has become more available. So the question is why not now? Because everything makes it possible to actually harness a lot of data now. So it's just a technological improvement have made it very possible for us to actually use data in more ways in the current time. So examples of data, when you like a TikTok video, when you play a game, the information about who scored what in the game can be recorded. So it's data. Your likes on social media, it's information about do you actually like that or not. So it's data, it can be recorded. And there are people applying it to do several things. like the weather forecast. If it rained the previous day, it's data that has been recorded, and people are now using it to forecast the future. If you have liked a music playlist, is an information, and they can now use that data to actually recommend more songs that they think you would like. So these are people that are data heads specifically. They have looked for how to harness data, how to practically apply it and use it to do something that is interesting. And this session is making you think about it in that light. This data that can be recorded, this compute that is now available, how do I make sense of it? How do I apply it practically? So this is my magic formula, 4 steps, because you need to have steps to become to doing anything. So my magic 4 steps to becoming a data head, and I'm going to just take you through it one by one, really, so that at the end of this session, you actually know that, okay, if I can improve my pattern recognition skills, if I can do the laborer's job of cleaning data to harness it, actually, if I can maybe throw up some predictions and build an ML model, then I can actually apply my data skills. Then I can see a problem and apply myself to solve it. Problem solving is where all of us in the data field are aspiring to get to. We're aspiring to see a problem, have all the data necessary to solve it, and actually solve it. So problem solving is when you know that, yes, I've gotten to that level. But before that, you need to actually build your pattern recognition skills, because data science essentially finds patterns in information. You need to build your skills to actually, because one thing you would notice when you're working in data science is that most data, even though it's information that can be stored, is not in a usable form. So you need to build your skills to actually know how to make this data that is collected in a useful form. So things like data cleaning, analyzing the data to make it useful is one of the obstacles you need to cross to become a data head. Prediction and ML is very interesting because it's something that is now possible. And if you want to solve problems with data, it's something you should actually know and pay attention to. For a quick, for a quick, just to get you to kind of be in the space of what pattern recognition actually means, I have an short interactive session that I would want everyone to pull up their browsers and actually do. So I would be asking, I think it should be in the chat. The link should be in the chat. Everyone can open it. So I would also open it on my screen, and I hope you all are opening it as well. This uh, is everyone there? Has everyone opened it? Just let me know in the chat if you have, so that we can proceed. Yes, let me know in the chat if you have. Okay, I see some people have. Yep, more people have. So let me just pull up my screen so that we can all do it together. Uh, yes. Okay, can everyone see my screen? Yep. Okay, so this is when you say pattern recognition, it's easy for you to just start thinking about something big, something out of this world, something that you cannot tangibly define. But with data, with computers, sorry, let me pause this. We need to start again. So let me first introduce it. So pattern recognition is simply you see something, and because you have seen it a number of times, you can tell what is going to happen. And this is the way that we have built the data, the technological capacity, technology rather, has made it possible for even computers, even algorithms, even neural networks to recognize patterns. And this is just an interesting demonstration of it, that you can start to draw something and the computer can tell you what it is even before you have drawn it. So does anybody have, okay, draw a dishwasher. I definitely don't know how to draw a dishwasher, but let's try. I know how to, I know how to draw a washing machine. Uh, This is definitely washing machine. Okay, this is a washing machine. So, and without even me having like the perfect drawing of a washing machine, uh, campfire, let's try. Let's see. So, I think we should stop. So, maybe one more BlackBerry. Let's see. Do I? This is definitely not a BlackBerry. So without even you, well, I think it's enough because I'll just stop. I'll start playing now. So let me actually go back to my slides. So without even you having the perfect drawing, without you even having like the perfect data, the computer systems have become so good that they can recognize what you're doing. The computer systems have become so good that they can recognize what you're doing. And that is pattern recognition, essentially. That's what pattern recognition is. Uh, Trying to get back to my slide. Let's go. Okay. So our goal here is to, as the computer can tell what you're doing, can recognize pattern based on the previous data that it has seen. As a data head, as a data scientist that wants to solve problems, you must be able to recognize patterns. And because when you recognize patterns, you see where automation can come in. You see where you can actually use AI to improve. You see where you can do a simple solution that can make people's life better. And I'm going to just be sharing like a brief, a practical example of something I did while I was in my first job. And it was just because of this skill of pattern recognition. And it's a skill that everyone, whether you're in data or not, you should be able to develop because when you develop pattern recognition, you become a better problem solver, essentially. So in my first job, which is very interesting, in my first job, I was on a team, and every month we usually prepare a set of reports for clients. So we have the data, we present it in Excel form we have it in Excel, we make some charts, then for each client, we make like PowerPoint presentations for each of the clients every month. And because of this skill of pattern recognition, I was like, this thing can definitely be better. Can I itemize every of the steps that goes into this? Because when you actually strip it back to first principles, everything is like, it's something that you do again and again. So you must be able to drill it down to the actual bare bones of what is the pattern that is being repeated here, essentially. And when I could do that, I saw that it was easy for me to create a program to do that. But if you cannot recognize, okay, this is a pattern, I just need to tweak some things each time to get what I want, you would not be able to automate processes. You will not be able to solve people's problems. So rather than ranting on, I'll just leave you with that, that the first skill you must actually pick up is pattern recognition. I'm looking at the chat now. I want to know if anyone was able to actually maybe get all the drawings that Quick Draw gave them. Anybody. No. Okay, someone did actually. That's good. So you can see that the computer itself missed guess. Okay, so 4/6 is fine, I think. 4/6 is really good. That tells you that the computer itself has developed a skill from pattern recognition. And that just comes by seeing data over and over again. And I find out that most times, us as people that we go in, we're in the world, we're interacting with things, but we are not very conscious of what we are seeing every day. And that's stopping us from problem solving well. Because the computer is focusing on the data that is seen again and again, it can recognize patterns. And it should be our job to look around. What is the pattern here? What can I see? What can I use this data that I am consuming every day to do? What problem can I use it to solve essentially? So the second skill that's for you to become a data head, for you to become someone that actually practically applies this AI data skills, pitching, everything you've done. The second skill is you need to know how to clean the data. You really need to know how to clean the data. And this is very, this is a very important point. And most people do not realize that even though you are saving, you are collecting data, most people do not realize that when you actually want to solve a problem with data, most times how the data is in the original form is not very useful. If it was very useful in its original raw form, everyone would be solving problems with data. But data is not very useful in the original form. And you must be able to say, okay, if this is the data I have, how do I make it what I want? And this is the very technical part of it. You need to learn things like Excel, learning how to clean data in Excel, learning how to analyze it in a chart to make it useful to somebody else that does not know what you're trying to do. You need to learn Python. I was going to do a Python session, but I didn't want anybody to not be able to follow through. So I just stuck with let's give everybody an overview. Let's give everyone the opportunity to pick up these practical skills that you can then go and build on each individually. So learning how to, you can, today you might start like maybe my pattern recognition skills are very good, but I do not know how to clean data. Even if I know that if I collect this data, I can solve this problem. The bridge there, I don't know it. You can decide to take a YouTube course on Microsoft Excel, on Google, or how to use Google Sheets well. So if you have, simplest example, you've recognized that there's a problem somewhere. The simplest example of being a problem solver is you can advocate that something should be done. And how you do that is you collect the data, you clean it up, make a chart, and say, this and this is a problem. We should pay attention to this. And that's what you see with people that advocate for climate change. That's what you see with teams in AI advocating for more women to be included in technology. It's because somebody has seen that there's a problem here. Women are not being represented. And somebody has sat down to collect the data, to analyze and clean it and say, okay, 30% of women, blah, blah, blah. And that prompts you to take action. That prompts somebody to take action. So that's what I'm going to say about data cleaning. It's the technical bit of it. If you want to become a data head, if you want to be someone that really applies these skills, you need to take a course. You need to practice on how to make the data that you are seeing, that you recognize the pattern, how to make it useful, how to make it appealing to somebody else. Then the next one, the next skill that is a nice to have, this might not, your problem solving might stop at advocacy. You might say, okay, how I want to apply data is I want to advocate. I want people to know what's going on. I want to spotlight the problems to people. And you can say, that's why I want to stop. But some people go further and say, well, I know that there's a problem, but advocating might not really solve it, might not really do what I want. But how can I maybe build an algorithm? How can I do something that can maybe make people go the next step? And the first idea that is coming to mind is you've seen a problem. You know that if this problem um is not solved now, if people do not pay attention to it, you know that there's going to be a problem in the future. But if you say, you cannot just say that in the future, 80% of people will die because of this thing. You are not good. You really don't know. And the models as well, they are not good. But you can take it a step further and you can say that I can build a prediction model to train it on the historical data and actually predict what the next 5 years would do. And this is something that is very interesting to me now because I am currently doing like my dissertation is around something like this. Is like I can see that there's a problem with youth unemployment, and I need people to be able to see how it will be aggravated in the future. So you can decide that, okay, the computer can learn the patterns and tell me what a future version will be. Today, I want us to do like a short interaction on training a simple ML model. It's going to be a very easy model, and you're not going to do any math. So don't be scared. When they drop the link, please click on it because you're not going to actually do any math. You're just going to provide the data with some provide the model rather with some training data that can be used to actually, yeah, teach the model something. So I am also going to change my screen. Please click the link. I'm going to change my screen as well to the link now so that we can all do it together. So that we can all do it together. So can you guys see my screen? Has anyone opened the link? Let me see in the chat. Has anyone opened the link? Has anyone opened the link? As anyone, I'm going to wait a minute for like 5 people to open the link. Okay, we have more than 5. Maybe make it 10. Maybe. Okay, 1, 2, 3, 4, 5, 6, 4 more people. 7, 8, 9. Okay, one more person, 10. Good. Okay, so we are going to train a model to do something, and I would give everyone a take-home assignment to actually see how good you can train a model. So you just click get started. You don't need to register. You can try it without registering. So I'll say try it now. You can create a new project. For this project, I want us to train a model that can recognize if somebody enjoyed watching a movie or not based on their comments. And this is a typical machine learning project that you see on the internet. People saying they are going to predict like if this was a positive review for the movie or if it was a negative review for the movie. So let's say it's a review classifier, but let's be more specific. A movie review classifier. A movie review classifier. And we're going to be recognizing text because text is how people write reviews. So you can do all these other things, but today, because it's the simplest one, we're going to be recognizing text. English is the language. For this, you can just do it in your web browser and create. So yes, this is created. So the first step to train any model on a prediction task, create any prediction algorithm or anything is you need to actually train the model. So we're going to be training the model. What I want this model to do is to recognize either a positive or a negative movie review. So I'm going to create a positive label, which simply means that this person enjoyed this movie. And the second label I'm going to be creating is a negative label, which means the person did not enjoy that movie. So I'm going to be looking in the chat. I'm going to start with the first example. For a positive movie, if I like a movie, I can say that was a beautiful movie. So that's my first example. That was a beautiful movie. If I hated a movie, I can say total waste of time. Waste of time. So in the chat, you can give me an example of how you would what you would review a positive movie and a negative movie. So I'm just going to be looking in the chat to see if anybody has any more examples for me. Best use of my time. Okay, so that's a good movie. Uh, Anybody have any negative? I greatly enjoyed, okay, positive. We can do that. Yeah, so best, okay. The best one, yes, that's a good one. You people are giving this model easy examples. Don't actually add questions. Very interesting. We need, yeah, more sad ones. So really very interesting. More negative reviews. Utter disappointment. Wish I never. Yes, that you must be very pained. So okay, very boring. Yes, more negative examples so we can have any more negative examples. You people don't watch terrible movies. There are very terrible movies outside. Maybe I should write terrible movie. That's a good one. Movie. Terrible movie. One more negative, one more negative, one more negative. Then we call this a day. Never ever watch this. Okay, warning other people. Okay, two more, then we'll take that. Never ever watch this. Okay, add example, and no point of watching this. And this will tell you in the simplest form why machine learning models have problems. So back to projects. So we give the model time to learn. So train. So you just press the train. The model will take its time to train. Uh, so it's still training. When it's done, it will let us know. You can also be doing this with your own examples on your personal computers. And when I am done training my model, I'll give you the opportunity to share how your model performed. And we will take a very interesting example. So the model is now trained because this has become available. So we would go back to our projects and make a prediction. Oh, sorry, back. Sorry, to actually test it. We don't need to leave there. So we now want to see if the model we have trained is able to classify a movie comment or a movie review as either a positive or a negative movie. So anybody have any movie review, you can just send it and we'll test our model. We will test our model. So new reviews, anybody, new reviews. Let me start. Um, good or bad? Maybe bad for the plot twist. Let's say, let me say, okay, somebody has, this was awesome. It made me cry. Okay, let's try that. Tests. So the model can predict it as positive based on how the little training data we've given it. So, and it has a 74% confidence of that. So this was good. This is the correct one. Please give me more difficult things to test our model with. So let's say test, great movie, is more confident that this is positive. And I'll talk about why it's more confident. So let's see, so inspiring. Let's try that. Test. So it's confident that this is positive. Some negative examples, guys. Let's see, let's see. Worst hour of my life. So at least it was 1 hour. Let's see. Test. So it's recognized this as negative. Good. This was a blast. Let's see. Let's see. Control A, Control V. Test. Positive. Okay. You people are not taxing this model. Let me see. Mm. So superficial.Ficial. I am clueless. Let's see if our model is that good. Okay, negative. Yeah, that's good though. How many examples do we train it with? Okay, let's try this one. Tests. They shouldn't have bothered. That's why is this model getting it? Let's see, 8 every minute. If we are giving it easy examples, we should have some misclassification by now. Negative. The acting was okay, but the plot wasn't the best. Let's see. I need to think of more difficult examples. You guys are giving this model. Okay, jaw-dropping. So this said it was positive, but with a 67% confidence, which in my opinion is correct because you're saying one part was good, but one part was not the best. So let's try this. Let's see what it gives us. Tests. Okay, yes, this is a good example. So, jaw-dropping plots, in my opinion, is a very good review. Like this was like that good that my jaws could drop. But the model does not understand that, and it classifies it as negative. And this is my first lesson on training data models, training prediction models, is that your prediction is only as good as your training data. In our training data, there was no data that had any nuance, that had any sarcasm, that had anything. So our prediction can only be based on what we have seen. So this is a good one. Thank you for who dropped this. Let's keep going with one more before we I saw one more, but yeah, that vanished. Okay. Yeah, this is a good point. Maybe we can, okay, not terrible, but certainly not memorable either. This will be the final one. Then I'll give you your assignment. Okay, maybe the next one will be the final one. Okay, this is negative. You got it. Well, this is actually average. I would expect like a 50% confidence. But this just tells you that the model is only as good as the data that you feed it in with. And this would actually lead us to our ethical section. So let's see. Oops, I did not copy that well. Let's see. Add me at the edge of my seat. Uh, tests. Okay, he got this. Yeah, he said it's positive, but it's with 15% confidence. That means he's not too sure. And that's because the data that we have used to train it did not have this type of nuance. So when we ask it something that has nuance, it doesn't really understand it. And we cannot blame the model because, yeah, we didn't just train it with that. So thank you guys for engaging. It was good to see all your reviews. We must have a lot of movie watchers here. So that's when you're building prediction models, this is something you need to think about. You need to think about it properly because the output you get is only as good as the inputs you put into it. And this, I'm trying to get through my slides so that we can also have like an interactive session. But for me, this is the goal. If I'm doing data, if I'm doing AI, if I'm learning all these things, the goal for me is to solve problems. That's why I'm coming to school. I want to see problems and I want to be able to solve it. And I think it's an important caveat that everyone in teens in AI, every one of you guys that are learning things now you need to have it at the back of your mind. I'm learning all these things to actually solve problems. You're learning it to make a career, you're learning to make some money, but at the end of the day, you're learning it to solve problems. And I think this was one of the things that teens in AI did for me when I joined the bootcamp. The Alina asked me what was the most memorable thing for me when I joined then. And it was basically that time we used to have they would ask us to pick any of your any problem you want to solve and actually build a team, solve that problem. And everybody obviously had like great ideas that he wanted to do. And we had like coaches that would come in and talk us through. And there was a particular session that I really liked. It was called a design thinking workshop. And what that section session was like, it was basically us ensuring that we were solving the right problems. We're solving problems that were problems for people, not problems that we thought were problems. So we actually did interviews with people to see, okay, what actually is the problem that we want to use all these skills that we've learned to solve. And it just left a big impression on me because I was like, I could have wasted all my energy, all my skills solving something that was not really a problem, targeting something that somebody might not have needed. So I think for me, if you're the apex of this practical application that I want you to go on with is you need to think about solving problems and you need to think about solving actual problems, problems that make a difference in people's lives. And I've pointed out some obvious professions of examples of people that are problem solvers. Consulting, if you're in a consulting career, the whole point of you consulting is somebody actually tells you their problem. You don't even guess. Somebody says, this is the problem I have, and you look for a solution to it. And data and AI can help you do this like very well, like very, very well. And I'm also considering a career in consulting. But yeah, that's by the way. Um, if you have AI products that are also solving people's problem, you have Siri that is a voice assistant. You have a problem, you say, Siri, can you do this? Siri does it. That's problem solving. That product, that AI product is problem solving, is solving somebody's problem every day, every single day. You have recommendation systems. I want to watch a movie on Netflix and I don't know what I want to watch. And I do not want to scroll through the entire catalog. But a recommendation system is saying, I think you would like this. That's problem solving. I don't need to waste my time scrolling through and trying a movie that I don't like, then now complaining, giving it a bad review. If a very properly trained ML system can say, I think you'd actually like this. So personalized content is problem solving, self-driving cars, all of those things. They are AI products that are actually solving problems. And it's something I want you guys to think about. It might be a problem that is in your community that is not obvious to everybody, but you are just thinking, how can I actually use this data and AI skills that I have learned to solve these problems? So yes, and this is such an important point in this, and I want everyone to listen to this. Is everybody still on? Is everyone still on? Just drop an emoji in the chat if you're still on. Drop an emoji in the chat, anything if you're still on. So I see that Yavuls is still on. Some people are okay, so I can continue. With AI and data, ethical consideration, you need to pay attention to it. And I'm going to frame it from 2 points. First of all, it is if you are training something on data that is generated by humans in our world, you need to know that our social interactions are biased. So if you're training something on human data, you need to know that there's a probability of being biased. And there's so many examples. I know Twitter trained a model that was going to predict something that was interesting in an image. So if you place two images side by side, Twitter's model was going to say, this is the more interesting picture, or this is the more interesting image. And they found out that every time you had that model to pick two people side by side, if you had a, let me not get this wrong, if you had Barack Obama and, sorry, yeah, I'm going to get, if you had, forget the names I'm using, but just take it like that. I'm not too sure of the names and I don't want to misquote. But let's say, for instance, if you had Barack Obama and somebody else, it was obviously the other way. If you had Barack Obama and somebody else, the model was always going to say that Barack Obama is the other way. I'm very sure it's the other way, but because I can't remember people used. It was always going to say that this person was more interesting. And that was because the people that it was a sophisticated data collection mechanism they used. They were tracking people's eyes to see what they paid attention the most to in a picture. Does anybody know that actually? Did anyone follow that Twitter scandal? They came to explain and said that there's a problem with the model because the people that they trained it on were biased inherently. So even if they were not intending to be biased, they were not intending to be racist, they were not intending to be that, the model was still that because the data they trained it on was inherently biased. And I know when I was also in the bootcamp, they brought Joy Bolwami that also spoke on something. I hope I pronounced that last name correctly, but she also spoke about something um quite similar, that she went to China and there were robots that were dispensing, I think, tissue papers or something like that. And she saw that these robots worked well for people that were white, people that had a fair skin tone. But she found out that she was a black person and she tried to use it and it didn't just dispense to her. And she was very puzzled, like, and you know, in China, they have robots, yeah. So, and in China, one other thing in China is you hardly see a black person. So they had not trained that robot on a diverse data set. So the robot did not think that a black person was a person because the data they used was inherently biased. And those people were not planning to do that. So that's why I called it good intentions and open communication. You need to have good intentions, number one. But even after your good intentions, things can happen. And that's why open communication is very important. You need to carefully consider that have I tried my best to actually make sure I cover all the lapses, to counter for social bias, to counter for things. Have I gotten a diverse data set and have I properly used it? And you also need to ensure that even after you take all those attempts, you need to put disclaimers. This is where I got the data to train it on. If you are using somebody's personal data, you need to tell them you're using their data to train a model. And if anybody asks you a question, you need to actually be able to provide them an answer. You need to be open about communicating whatever you're using your data for, whatever you're using people's data. And you need to be open about communicating which data was used in training any of your models or doing any of the things. That's why you see in research papers, they have a chart. Underneath it, they put the source of the raw data. And it's something you must learn because it's so important. So questions you can ask, are you getting people's data with permission? Are you monetizing people's data? And this is very interesting with generative AI because we're seeing that I think it was New York Times that is suing Microsoft and OpenAI, I think, for training their generative models on news articles without permission. So these are things that you must consider if you're trying to become a data head, become a problem solver with data. Okay, we have some time, so I'm just going to gloss over this. There are industrial uses of AI. You might decide that this is nice. I can identify problems outside and solve them, maybe by being a consultant, by doing a chat, by building an AI product. Some people can decide to do that. But some people might say that actually, I want to play a part in the industry. I want to be doing AI, I want to be doing all these things, I want to be using data to solve problems, but I do not want to be the one to first do the pattern recognition to spot the problem. I do not want to be the one to now clean the data. I don't want to think of the entire value chain, but I want to play a part. And that's where fitting into an industry comes to play. So in several industries, yet if you just Google, you see industries that are doing interesting things with data, and you can look for a way to key in, maybe by doing a project that is related to that industry. I've heard people say that that works well. If you pick a project, you want to do it, you can send me a DM. I'm actually looking for a new project to pick up, even though I don't have the time. But when has that stopped us? So you might think that you might want to fit into an industry. So this is just one case study. The healthcare industry, we know different ways that AI is helping in the health industry. We know that the people are talking about personal diagnostics now because the doctors to patients ratio is not sustainable. So they're trying to use personalized medicine, and that's AI. We don't know how good that is now, but it's a possibility. You see AI that is speeding up diagnosis. You see AI that is in drug discovery. Diseases that people thought were never going to be curable. We're seeing AI tell us that it's possible. So you can just play around all this and see where you fit in and just try to position yourself either as an independent problem solver or as somebody that is problem solving in an industry. So that's the end of my presentation. I was keeping to time, which I'm very happy I did. If you have any questions, I'm around. You can follow me on any of the social media and reach out to me. I'll be happy to answer any of your questions.
So, moving on to the questions, we do have a few. I'll just read them for you. So, Blessing? Yeah. The first question being, how do you balance using AI for innovation while making sure it's ethical and fair?
Can you come again with that?
How do you balance using AI for innovation while making sure it's ethical and fair?
The slide I shared is a very good starting
Yeah.
point. Good intention and open communication, because even after you have good intentions, you might think you've covered all the gaps, but there might be something that in production triggers your model to do something that was not anticipated. So you need to let people know how you train this model. That's why people publish research journals and say, this is the process, this is the methodology. This so it's such an important thing. You have the good intention, but you need to openly communicate. So however you're thinking about, let somebody know that it's an AI model that is responding to you. Even though it's innovative, let people know that this was an AI model that actually did this. Don't let them think it's a human that is speaking to them when you know that it's not. So you have to just think of those two pillars are very crucial. Good intention, open communication.
Yeah. And the second question for you is, what are some cool projects and websites you recommend us to try?
This is something me too I'm looking for. I'm looking for cool projects. There are so many there are so many generic projects, but when you build your pattern recognition skills, and this is because like cool is relative to you, is relative to your interest. I might not be interested in maybe movies. I have a professor that is very nerdy, and he said after watching a movie, he saw one of these sci-fi movies and he decided to code that up. So you just need to be very attentive to that's this pattern recognition is the first step. You need to be attentive to what actually ticks those boxes for you. What can you spend long hours debugging? And you see it through because there's when I first started, I said I wanted to do a project. I was like, yes, I'm going to do it. And for me, I like to gift my friend things like on their birthdays. I would want to give them a really nice gift. So I was like, okay, can I have a gift recommendation system that I would just put my some of the things I know about my friends, and it would recommend the gift, tell me the store to buy it. And I started that project, but I didn't finish because it was a lot of work. But like, yeah, you just need to say what is important to me, what do I like, and you follow up from there.
And a very long question for you, actually. What are your thoughts about AI potentially having the ability to replace even ones of the most skilled? Such as in the medical industry, AI models are almost 90% more accurate and faster in recognizing diseases and cases.
I'll need you to take that slowly because
Oh,
yeah, you
sorry.
messed it.
What are your thoughts about AI potentially having the ability to replace even the ones which are more skilled, such as in the medical industry, AI models are almost 90% more accurate and faster in recognizing diseases and cases than the doctors, actually. So,
Okay. The first thing I would challenge you to do is when you state a statistic like that, we need to know your source because when you work in the data space, you see that most of the statistics people are throwing around are not actually valid. They are not like they're not real. People sell narratives with these statistics, and you need to be able to validate it. So that's just a side quest. But I do think that AI is going to replace people. But how do I put this? I'm an optimist, and I think that there are some jobs that we shouldn't be doing. I openly say it. I think that there are some jobs that AI better do. Yeah, I don't like, it's like, I do not like to do drudgerous tasks. I do not like to slave away in a job. So I think you should start to look at it from that point of view that what are the jobs that humans should be doing and what are the jobs that AI should be doing, and not trying to struggle with the capabilities of the models. If the models are good at a job, maybe they should be doing it.
yeah.
Yeah, maybe they should be doing it. And you should now start to see that where should I play? Where can I play? And this is something that every one of us, and we are all navigating it together. I do not know the answers, but it's something I shouldn't, your perspective should be like, there are more interesting jobs out there and we just need to find them. We actually just need to find them and we need to get paid for it. So it should make you think about it more.
Yeah, there are like 100% more jobs that don't require AI. So maybe we have to look into that as well. And the other question is, how easy is it to make the machine learning 100% sure?
This is such an interesting question. And you'd see that in machine learning, we're not trying to make it 100% accurate. That's this, yeah, it's the funny thing about it. And I can give you a lecture that one of my professors is giving me, but I'll just tell you the goal of machine learning is actually generalizability. So you want the model to be able to generalize on cases it has not seen essentially. And if you want a model that is 100% sure, you want it to learn everything in your data, you can easily do that. That's a linear regression does that. Like just train it exactly on your data and it minimizes the error, explains all the residuals. But if you want a model that is good in actual real life situations, you want it to just learn the trends. You want it to learn the general pattern. So you're not really pushing for training sample accuracy as such, but you're pushing for generalizability. And when you start to actually experiment with these models, you see that a model that might have a 80% training accuracy can be better than something that has 90%, because when the validation data comes, when the test data comes in easy English, when you put it in the real world, it
Yeah.
needs to be able to generalize to those people that he had never seen. And if he has 100% on people that he has seen, there's a possibility that he's not going to generalize on people that he has not seen. So the goal is not for training accuracy or anything like that. The goal is for generalizability. And what that means, to answer your question now, is that you need to have a representative data set. You need to have a good enough data set to train it. And you need to have a good enough process, a good enough algorithm, a learning algorithm to actually train these models.
Okay, so the last question for you is, do you think AI's advantages outdo the disadvantages?
This is an interesting question. I'm not a thought leader, so I'll provide no opinions on this. But I worked in a data center, and if you know anything about data centers now with AI and everything, they are serious environmental consequences. There's serious waste consequences. I work in a data center in Nigeria, self, not a data center elsewhere. And in Nigeria, where there's no lights, you see that these data centers and things like that are running on generators that produce they pollute the environment. So I just provide you with that. There are disadvantages, there are advantages. Anybody should form their opinion. Yes, like
Yeah,
I'm not contributing to that.
nice take. And just like that, we have reached the end of the boot camp. I hope everybody has got an insightful learnings from this session. And we have reached the end of the bootcamp week. What an incredible journey it has been, filled with knowledge, insights, and inspiring stories that will help shape our Techathon experience. A huge thank you to your phenomenal speakers for sharing their time, wisdom, and experiences with us. Your contributions have been invaluable and guiding and empowering the next opportunities and next generation for the change makers. Remember, if you have not taken advantage of the AI adventure all access offer, you can still have the opportunity to scan the barcode on your screen right now, as this will be available up until the 17th March of 2026. And it has been very practical and insightful experience so far this week. And thank you so much for being with us this week. Please don't forget to share your experiences as a post or on LinkedIn. And wherever possible, please be kind. And I hope this was an insightful week for you all as well. And thank you so much for having you all. Thank you.